Now in this little piece we're going to talk about another kind of one-sided limits, those that involve asymptotes. So for example, when we look at y equals 1 over x squared, which is from our zoo, it looks like a little volcano. Now the thing about it is, if I'm trying to do just the limit, what I would want to do is take the fingers of my right hand and crawl up that way, and take the fingers of my left hand and crawl up that way, and I want the fingers of my left hand to be at the same height of the fingers of my right hand. Now they never crash into each other, but they both go higher and higher and higher and actually get closer to each other. So what we're going to say is the limit as x goes to 0 of the function equals infinity. What we mean by that is the further up the graph you go from both sides as you go up the graph, the fingers get closer and closer to each other and they go higher and higher. So that's actually what that means. Another thing from our zoo is y equals 1 over x. That's actually a hyperbola. It looks like this. You can see that the fingers of my left hand, as they go down the graph, go down very, very far. And what we want to be able to say then is that the left-handed limit, doesn't crash into anything, is negative infinity. But all we mean by that is the closer your fingers get to x equals 0 as they walk along the graph, the further down they go. Now, what about the right-hand side? The right-hand side says, ignore the left-hand side, just walk the fingers of your right hand, do-de-do-de-do-de-do-de-do-de-do-de-do, and see what happens to the height. Well, when I write this down, what I mean is, as you walk the fingers of your hand on the graph of f of x, your right hand, closer and closer to 0, they go higher and higher and higher. Right? We're not saying that when you plug in 0 you get infinity. We're not saying you ever get to infinity. Unfortunately, every time we see the symbol infinity, it's going to mean a whole paragraph in terms of talking. But this just should mean from the right-hand side of 0, your fingers are going way up. This one should just say, if you use the fingers of your left hand coming from 0, your fingers should go way down. Now, the other kinds of asymptotes we can see are the ones way to the right and the ones way to the left. I'm writing down the function y equals 1 over 1 plus e to the minus x. You're going to see this a lot with populations, or for example, number of people who have caught the flu or the coronavirus. That function shows up all over the place. But it doesn't have any asymptotes in the middle. In fact, it doesn't have any vertical asymptotes at all. It has two horizontal asymptotes, and that's actually what these kinds of limits are good at describing. So for when I look at this, I see x arrow infinity. Well, we already know that's end behavior, and that means way to the right. So what we're saying here is, we're not saying that if you plug in infinity, way to the right, you get into the function, you get 1. We're saying if the fingers of your right hand walk further and further to the right, the closer the height of your fingers get to 1, and you can see that's very clearly true here. Now, what was this one going to be? Well, we know from end behavior that x arrow minus infinity means we're going way to the left. So this says if the fingers of your left hand are walking onto the graph further and further to the left, the height of your fingers as they walk on the graph get closer to 0. Big paragraph every time we see infinities for answers. But that finishes our discussion on one-sided limits and asymptotes.